Arithmetic series is when they have a common difference and you add them. There's two formulas. The only difference in the first one is it has D, not Tn. The difference in the second one, it has Tn, not D. Both of them have N and T1. That's non-negotiable. And tomorrow, we're going to remember to freaking record. I just said freaking. Oh, twice. Darn it. I'm not re-recording.
Too late now.
Too late. Oopsies.
Yeah.
Here we are. Look at that. Okay. This one says determine the sum. So I know it's going to be an SN formula because SN stands for sum, right? Crazy. Now it says arithmetic series. So that means I am going to go to my formula sheet and I'm going to go under the arithmetic series column. And then I'm going to see two SNs and I'm going to use one of those. I am not going to go into the geometric and pick those SNs because that's just dumb, right? That would be just silly. Who wants to do that? Not me. So we are going to write down our knowns. We're going to write our knowns, which means it's what we know. Okay? What do we know?
Tn.
We know Tn. Tn is what? The last one.
Yeah.
Negative 86. And T1 is what? 14. Okay. And D is what?
Negative.
Yes, because I'm going to go term 2 minus term 1, which is negative 4. We're not going to do this one. So I'm going to use up a little bit of this one, and then B is going to go here, just so you know. Okay? For warning you. All right. What I told you is the first formula you had D but not Tn. The second formula you had Tn but not D. We agree? But what was non-negotiable is I needed to have term 1 and I needed to have N. We agree? Okay. We don't have N. This is a problem. This is one that I would bold. I would star. I would make pink. I would highlight. I would say, look back at this. It's a two-stepper. So you really do start, like, get awake after lunch, hey? Yeah. All right. So we don't know N. That is non-negotiable. I know that I'm going to have to use the second formula. Well, I know I'm going to want, I could use the first formula. Why I would choose that, I don't know. But I know I have to use the second formula because I know Tn. We agree? And the second formula is, I'm going to write it over here, Sn equals n divided by 2, T1 plus Tn. I know I'm going to use that because I have Tn. My problem is I don't know n. Any idea how I could figure out n? Rather than just adding them all up miraculously. Using the old formula. The one we learned yesterday. This is why I star this one. Because if we are missing n, or we are missing T1, we are going to have to use the sequence formula from yesterday. Because the sequence formula, as long as I know T1, D, and N, it doesn't matter if it's being added or subtracted in between, right? I can still find out the number of terms that was there. So I'm going to do that. So step 1 is actually to use the Tn equals T1 plus N minus 1D formula. So if I'm missing T1 or I'm missing N for these formulas, I have to use the sequence formula from yesterday. What's my Tn?
8 minus 86.
Yeah, negative 86. T1 is 14. N I don't know. And D is negative 4. And it's multiplied. So just like we did in the previous example, we're going to subtract 14, which is negative 100 equals negative, oh, sorry, I'm not going to go out of order, n minus 1 times negative 4. I'm going to divide by negative 4. Yep. And I'm going to get 25 equals n minus 1. So n equals 26. And now I can go to step 2. Because I actually have n. There are 26 terms in this series. Does that make sense? So you need N, you need T1, they're non-negotiable. If you are missing either one of them, you have to use the sequence formula before you can use the series formula. So now, I'm going to find Sn. And in for n, all these n's I can put 26. So I'm actually finding S26. I'm finding the sum of the first 26 terms. That's what that means. So I get 26 divided by 2. And T1 is what? 14. Plus Tn, which is negative 86. Now, could I use the big formula? Because I have D? You could actually use the big formula because you have D, but we would never choose that if we have Tn, because you're making your life worse. Don't do that. Could you double check it? Sure. So, these are being added together. So I'm going to get 13 times 86, negative 86 plus 14 is negative 70. Rhymes with flu.
Blue.
2.
2. What's 13 times 72? Negative.
We get negative 936. Negative 936.
936? Now we have to say, does this seem realistic? So my sequence starts at 14, 10, 6. Very quickly I'm going to be out of the positive numbers, correct? And then I'm going to have a whole bunch of negative numbers, right? And I'm summing them all up. So does it seem realistic that negative 936 would be the first 26? Yes. What some people will do is, like, they'll get an answer and it'll be like positive 1,000. And I'm like, does that make any sense? And they're like, no. And I'm like, then don't put that. Go back, try again. Okay, so it should make some sense. You guys are going to try B in that spot. We're not doing C. So try B. So we'll try this one out. We're going to go term 1 equals 5. Tn equals 26. D equals 6.5 minus 5, which equals 1.5. And then I need to find out what n is. So I'm going to do 26 equals 5 plus n minus 1 times 1.5. Supposed to be subtract. An excessively large eraser. So subtract 5. 21 equals n minus 1 times 1.5. Dividing by 1.5 actually makes it bigger. What's 21 divided by 1.5? Should be 42 divided by 3, 14. And add 1. So n equals 15. So if you wanted to do the math yourself, you could go, I'm going to put it down here, I'm going to erase it. So if I went 21, it would be divided by 1.5, which is 3 halves. So I was saying it's going to get bigger. You're going to go 21 times 2/3. So it's going to get bigger, which is 21 times 2, which is 42, and then divided by 3, which is 14. Which your calculator will do for you as well. But remember, you flip and multiply when you divide. Add 1 and get 15. And then we're going to do S15 equals 15 divided by 2, which is going to be decimal. T1, which is 26, plus Tn, which is, oh, that is Tn. 5 plus 26. So it equals 7.5 times 31. What's 7.5 times 31?
232.5.
232.5? Do you agree?
Yeah.
Now, does a decimal answer seem like possible? Yeah, because we're adding 0.5 each time. So we're either going to get a 0.5 as an answer, or we're going to get a whole number if the two 0.5s join together, right? So it seems realistic. Now we're going to look at example 2. For each arithmetic series, determine the the indicated term is what it should say. I don't know where that got cut off. So we're trying to find the sum of the first 12 terms. The indicated sum, it should say. So we want the sum of the first 12 terms. So this tells me what? N. N equals 12. What else can I pull from this? Anyone? Tn? Is there a Tn? A T1. There's no Tn because we didn't give it a finite amount, right? So T1 is 4. What else do I have? I have D, which I can either do 14 minus 9 or 9 minus 4. And we want the sum. Now, I told you T1 and N are non-negotiable, which we have, right? But this one I have D and no Tn. So which formula am I going to use? The first or the second, the long or the short? The first, the long. So the formula is Sn equals n divided by 2, bracket 2t1 plus n minus 1d. And we're finding S12. So it's 12 divided by 2, 2 times 4 plus 12 minus 1 times 5. So it's 6. 2 times 4 is 8. Plus 11 times 5 is 55. So I'm going to get 6 times 55 plus 8, which is 63. 378. It doesn't seem realistic. I'm going 4, then 9, then 14, then 5 more is 19, then 5 more is 24, and I'm going to add them all up. First 12. Does 378 seem realistic? Yeah, it seems like it could be. If it was like 1,000, I'd be like, well, that's a little fishy because I have to add 12 terms, not 24. Something larger. You guys are going to try this one. It's a little extension with some X's. I will help you get D, though. Let's look at D. How do I find D? Term.
5x.
We can do 5x minus 3x, which is how many x's? 2x. Or I could do 3x minus 1x, which is still 2x. Try it out. So T1 is x, n is 20. So we're going to go S20 equals 20 divided by 2. 2 times T1, which is x, plus n minus 1, which is 20 minus 1, times D, which is 2x. So we're going to get 10, and then you get 2x, and then this is going to be the same as 19. So 19 times 2x is 38x. So I'm going to get 10 times 40x. So it's 400x. Which it should be something and then x, because x plus 3x is 4x plus 5x is 9x. Like I'm just adding x's, right? So 400x seems realistic. When you're done, flip it over. The next one says, for each arithmetic series, determine the number of terms. So I need to find n, correct? I have T1, they gave me Sn, and they gave me Tn. It says arithmetic series, so I have two options. Which one did they give me? They gave me Tn, so I'm going to use the second formula. My second formula is Sn equals n divided by 2 T1 plus Tn. We know Sn, it's negative 950. equals n, we don't know, divided by 2. T1 is negative 2 plus negative 74. So we're going to get negative 950 equals n divided by 2 times negative 76. So what you can do, I'm going to split it up into 2 steps. But I'm going to get rid of the negative 76 first, and it's being multiplied. So what's the opposite of multiplication? Division. So I'm going to divide by negative 76. Now, n is the number of terms. Can the number of terms be a decimal? Can there be like 3.2 terms? That makes no sense. Can there be a negative number of terms? No. If you get a negative for n or a decimal for n, rethink your answer, because it makes no sense. What's negative 950 divided by negative 76? 950 divided by 76, sorry? That's okay. We're not at n yet, right? N divided by 2. How do you get rid of a division of 2? Multiply. And when you multiply a decimal, you'll make it even, right? 0.5. So we're going to multiply by 2. 12.5 times 2 is 25. So n equals 25. You try B. Okay, so we're going to get Sn, which is negative 210, equals n divided by 2, bracket T1, which is 20, plus Tn, which is negative 40. Negative 210 equals n divided by 2 times negative 20. So I can divide by negative 20, and what do you get? 10.5 equals n divided by 2, multiplied by 2, and you get? These ones say, for each arithmetic series, determine the 12th term and the 12th partial sum. That's going to be what you're going to try and figure out what the heck I'm asking you. So if I say 12th term, I'm not asking for sum, am I? Just the 12th term. So I want T12. If I say 12th partial sum, I want S12. So you have to use different formulas, right? So let's write what I do have. So for this, I have T1, which is 3. And I have D. D is, negative 1 minus 3, which equals negative 4. Now, this is also where your brains will go. You're like, I don't have n. You do. They gave it to you. Honestly, when it's given to you like this, most people can't find it because it's given. I don't know. But n equals 12. So for T12, I'm going to use the T formula, right? Tn equals T1, my brain stopped, plus n minus 1d. Tn is T12 equals T1, which is 3, plus 12 minus 1 times d, which is negative 4. So it equals 3 plus 11 times negative 4. So it equals 3 minus 44. So T12 equals negative 41. Now, does that make sense? I'm starting at 3, then negative 1, then negative 5. Does negative 41 seem like realistic by the time I get to the 12th term? Yeah. And then I want S12. S12 equals, which can I use? I can use actually the shorter formula. People will say, but I don't have the last term. You actually do, you just found it. This is the last term, right? You just found it. So this is Tn. So you can use that 12 divided by 2, T1, which is 3, plus Tn, which is negative 41, because you literally just took the work, did the work to figure it out, right? Because the last term of S12 would be T12. Does that make sense? So we're going to get 6 times negative 38. $228 negative. And then we're going to go to example 5. You're going to try them. All right, so this one says, for the arithmetic series, I gave T1 is 8, Tn is 68, Sn is 608, and I want n. Which formula? First or second? Formula am I going to use? First or second? The second one, because I gave you Tn. So Sn equals n divided by 2, bracket T1 plus Tn. So Sn is 608. N divided by 2, I don't know. T1 is 8. Tn is 68. So I get 608 equals n divided by 2, bracket 76. Divide 608 by 76, and what do you get? What's 608 divided by 76? 8? Thank you. 8 equals n divided by 2. And then we have to times it by 2. N equals 16. The last one gives you D, Sn, N, and T1. So I'm asking for T1. I gave you N. Those are non-negotiable, right? And then I gave you D. So you're going to have to use the second formula, right? Because we don't know Tn. You could somehow try and figure out Tn and then do it, but it would take you longer. So it'd be easier just to use the first formula. So Sn equals N divided by 2, bracket 2T1 plus N minus 1D. Sn is 279 equals 18 divided by 2, bracket 2T1 plus 18 minus 1 times negative 3. $279 equals 9, bracket 2T1 plus, what's 17 times negative 3? 17 times negative 3. Negative 51. Now I can't deal with the bracket until I get rid of the stuff in front of it. The stuff in front of it is the 9. How do I get rid of a 9? Anyone know? Nope. What's the 9 doing currently? Yeah. So currently, oh my gosh. So currently the 9 is being multiplied by that bracket, right? How do I get rid of a multiplication? Division. 27 divided by 9 is 31. So 31 equals 2T1 minus 51. How do I get rid of a minus 51? You just add it. So I get 80 2 equals 2t1. Divide by 2. t1 equals 41. So I picked one from each. They're kind of like the examples we did. Number 1 is like that example where you have to find n first. So you're going to have to use Tn, the Tn formula first to get n. And then you'll be able to do the rest. So it's like that starred one, that bold one, the one I told you to highlight, right? 1, B, and C are like that. And then 2, 3, 4, 5, 6 are like the examples we did. Just one of each. Just so you know, I'm going to show you, one second, once I stop recording.